All right, welcome back to another LeetCode video. We are going through bit manipulation problems. We just completed reverse bits, and now we are going to attack the missing number problem, which is also a LeetCode easy. It's LeetCode 268, and we're given an array of numbers containing n distinct numbers in the range from 0 to n inclusive. Return the only number in the range that is missing from the array. Right. Okay. We should only return the missing number. Okay, interesting. Well, I suppose that, we've learned the trick with the XOR to find numbers that appear only once instead of twice. I think we can use that trick here again. Now we're given an array that contains numbers once, and one number is missing in that array. N distinct numbers and one is missing. So let's see. And all the numbers in the array are unique. Yeah. So what we can do, we could just iterate over all of the numbers and XOR them. But we also have to XOR all the numbers from 0 to n into that result. So that will essentially turn this problem into find the missing number problem. Or find the number that occurs only once. So we will have a little for loop for I, n in enumerate nums. So now I is kind of our second number, and the result is going to be 0 in the beginning. And we're going to return the result at the end. And now all we need to do is we need to XOR the result. XOR equals n. But this wouldn't give us a desired result. But if we also XOR it with I, we can ensure that all the numbers in the range occur in nums, right? Now, let me see. The length of nums is... So I'm wondering, so is this array 1 too short or no? We might have to XOR result with n at the end as well. But I'm not 100% sure. So the length of the array is 3, so n is 3, right? Oh yeah, so that means when we iterate with our variable I over the length, I will only assume 0, 1, 2. But not 3. So we actually have to XOR the result with the length of nums. And we can just, well, we could just put this in the beginning actually. And that should be everything that is needed. So this is linear time, constant space. Let's see if we got this one right. And it looks like we're on the right path. Right, yeah, so cool. So that's how to do that. You just turn this into a problem where you can use XOR. By adding XORing with every single number in the range from 0 to n, inclusive n. And then when you XOR it with all the values in nums, only one of them will, one of the values in that range does not occur in nums. So, and that's the value that will remain in our result at the end. So, right. So that concludes another bit manipulation problem.